In these videos, we're going to see how to model the electrical systems and solve the ODE problems. So in these questions, we have a 2-volt battery connected to a series in which the inductance is 1/4 of Henry and the resistance is at ohm. Determine the currents if the initial current is 0. So we can draw the diagrams out. So we have 2 volt of battery. So this is the battery symbol. So 2 volt means 2 volt of 9 volt. That means the total here is 8 volt. And that is the power. We denote it as E symbol. And then this battery is connected in series with a resistor R. So given here is 8 ohm resistor. And then is connected to the inductor. Okay. So this is the series circuit. So inductors is represented as L, and this is 1/4 of Henry. Okay. So we need to find the currents. Okay. So that means assume that when we connect this circuit to 8-volt battery, we have these currents I here. Okay. So this I is a function of T. So how to find the IT? Okay. So this is our initial conditions. That means at time t equal to 0, we get I equal to 0 ampere. Okay, we can write the Kirchhoff voltage law, which is the summations of the voltage, okay, in this cross loop must be equal to 0. Okay, so that means we have this supply voltage 18 volt, and then minus the potential drop here across the resistor, which is we have a minus IR, and then we have this inductor. Okay, so when current pass through inductor, we have the voltage drop, so we put a negative sign, and the voltage drop of the inductor is the rate of change of currents times the inductor value. Okay, and that must be equal to 0. So we're going to substitute the value. In our case, the R is 8 ohm and the L is 1/4 Henry. Okay, so we're going to substitute the value here. We have 18 minus 8I minus 1/4 di over dt equal to 0. Okay, now we want to convert this into a first linear ODE. So we're going to convert this, or rewrite this into first linear ODE. Okay, so if we convert this, we're going to move this di dt to the left. Okay, so these ones we have plus 8I is equal to 18. Okay, so after the conversions, so from this we going to multiply all the whole equations by 4. So we get a coefficient value for di dt is 1. Okay, here we get 32. I equal to 72. Okay, so this is equivalent to the form of y prime plus pxy, okay, equal to qx. Right, so from this case, we know what is the px. So that this px is equal to 32, and our qx is equal to 72. So we find the integrating factor, which is exponential px dx. So in this case, we have exponential. So the px is 32, dx is changed to time dt. So we have exponential 32t. Okay, and then we're going to apply the formula to find the currents. I is equal to 1 over the integrating factors exponential 32t integrating our integrating factor, then time the qx here is 72, then dt plus c. Okay, so if we do the integrations, Okay, we do the integration of exponential 32(3), then we get the 72 exponential 32t divided by 32. Okay, and then this is plus c. Okay. Now in this case, we need to solve for the c value, the arbitrary constant value. So we're going to use the initial conditions here, okay, which is at time t equal to 0, I is 0. Okay, we substitute here. In this, I equal to 0. So here we get 1 over exponential 0 is 1. And then we have the 72 divided by 32 plus c. So we get what is a c value, which is equal to minus 9 over 4. Okay. So now we have the c value, we substitute back. Okay. So I is equal to 1 over exponential 32t. We have this 72 divided by 32, we get 9 over 4 exponential 32t. C is minus 9 over 4. Okay, so we can rewrite this. We multiply the term inside. Here we can eliminate the exponential 32t for the first term. So we get 9 over 4. And here we get 9 over 4 exponential minus 32t. So this is our equations, okay, or solutions for the current flow in that series circuit. Okay, so in this term here, what we can see, we have two terms. Okay, so the first terms we get 9 over 4, and the second term is minus 9 over 4 exponential minus 32t. So in that case, this minus 9 over 4 exponential minus 32t is called a transient term. Okay, that means this transient terms is going to die out. Okay, as t goes to infinity, so the I will become what? I will be have a constant value, which is 9 over 4 ampere. Okay, 9 over 4 ampere. Okay, so this value, which is the first term, 9 over 4 ampere, is called steady state current. Okay, it's called the steady state current.